In this class, we're going to take a look at how you differentiate the trigonometric functions, sine and cosine. So these are very straightforward, but they're also very popular. You're going to see these in a lot of scenarios where you've got to take derivatives, and sometimes these will filter into the other rules, like the product rule or the quotient rule. So knowing how to differentiate these efficiently, without too much thought really, and having done a little bit of practice, is a really great skill to have. In fact, it's a really necessary skill to have because you will see these a lot. Right, so we're going to check out these examples in a moment, but let's just have a think about the rules first. So like I say, very straightforward. So the way it works, the derivative with respect to x of sine x, so in other words, you're differentiating just sine x, just the sine function, is just the cosine function, positive cosine function, okay? So in other words, the derivative of sine x is cos x. Or you might just say that x goes to cos, or sorry, sine x goes to cos x. Might be one way to remember it. Similarly, but a little different, is the fact that the derivative with respect to x of cos x goes to sine x, but it's a negative sine x, okay? So sine goes to cos goes to negative sine. And there's a few different ways you can remember that. Some teachers like to draw a little kind of circle, where the circle going one way is positive and one way is negative. You'll see in various ways to remember it in textbooks, and sometimes that can be the challenge with the differentiation rules, because there are quite a lot of them, is remembering just like how the rule works. But this one you can probably just remember. It is fairly straightforward. It's very easy when you start off with this rule though to get the positive and the negative muddled. So you just have to learn that sine goes to cos goes to negative sine. Now, just to generalize these a little, because these are very simple versions of sine and cosine, but we can generalize it by considering the function not only sine x, but let's say we wanted to differentiate sine ax. Now, that requires the chain rule. And it requires the chain rule because we've got a function inside a function. Now, you might not be familiar with the chain rule at this point, so let's not worry too much about the mechanics of that. If you learn the chain rule in the future, or maybe by watching the class in this series, you can then take that back to basically this definition here, and you can say, hey, that was a chain rule, but for the time being, it's cool just to basically remember how this works. And how this works is that basically you've got the sine function with an ax function inside, and that's a composite function. That's how the chain rule works. And the chain rule says that you take the derivative of this kind of overall function. So the derivative of sine ax using this rule would be cos ax. But the chain rule also tells us to then multiply this by the derivative of the inner function. And the inner function is ax, and using the power rule, the derivative of ax is a. Now that might sound very complicated because I'm talking about power rules, something called the chain rule that you might not even have heard of at this point. But basically, the derivative of sine ax becomes a cos ax. Now in reality, remember a is going to be a number, so it's going to be a scenario more like this. And basically that number just comes in front, okay? That's all you really need at this point to remember. But it is good, and this is why I've put it out there, it is good for you to know that this is a result of the chain rule. And later on, once you get further into differentiation, you'll be thinking more carefully about the fact maybe that this is the chain rule. Okay, similarly, the derivative with respect to x of the more general form of cosine, which we could call cosine ax, unsurprisingly, it's the same rule here, minus, but the a comes in front, so we get minus a sine ax. One common mistake with these is to get the a in front okay, to remember to do that, but to make this into an x and drop the a. That's a really common mistake, but just try to avoid that one. Okay, so we've got these two forms in this more general form, and you'll be using kind of both. You'll see a lot of just sine and cosine, like sine 1x, just sine x and cos x. So you'll see those in a lot of different differentiation problems. Okay, so just turning our attention to the examples, we can go straight into these. There's no prep work required. There's no getting the function into a differentiable form. They're already in a differentiable form. This one here, we can just directly apply this rule. So the 4 comes in front, and sine differentiates to cosine, and we remember to leave it as 4x rather than sort of powering it down to x. Okay, one little thing about this, so just to put out there again, the reason why the 4 is in front is not just because there's a 4 there, it's because 4 is the derivative of 4x. So when we come to this guy here, we're going to have to think more carefully about the derivative of this kind of internal inner function in that composite function. So yes, the 4 comes in front, and that's what you'll be doing most of the time, just pulling that number in front. But you should remember that that 4 there represents the derivative of 4x. Okay, cool, right, let's move on. So checking out this guy, so we can go straight again into our derivative. We've got a sine function again. This time there's a coefficient, a number in front. When we multiply the 2 in front, it's just going to combine with the 3, multiply to the 3 to give us a 6 sine 2x. Okay, easy, right? And then this guy here, we're just switching it up to a cosine function. Remember, cosine differentiates to negative sine, so you just need to remember to include your negative in front. The derivative of 4x is 4, or you can think of it as just pulling that 4 in front. So this time you're going to get a negative 2 times 4 to give you an 8 cosine and then 4x. This part never changes. You never notice that we've never switched this part up. That's always one good thing about differentiating the trig functions. You just kind of pull that term down. Okay, so carrying on our little journey here. So this guy, similar format to this one. It's just a fraction inside the bracket. That makes really no difference. It just means that's the number that we're going to multiply in front. So it means that this time we've got the 1/2 multiplying to minus 4, which would give you minus 2. But remember that cosine differentiates to negative sine, so there's going to be an additional minus there. Now you could write this one over 2 lines if you wish. You could write that it's going to be the minus coming in front because when you differentiate cosine you get negative. You've already got a negative there, so you could, if you wish, use a bracket and do this over 2 lines, and then the 1/2 times minus 4 is minus 2. Cosine differentiates to sine. I just realized I did an incredibly silly thing here, didn't I? I left this one as sine, when of course it should have been cosine. Obviously that was a deliberate mistake to see if you were paying attention, and I even repeated it down here just to make doubly sure that you were paying attention. So okay, just swiftly moving on from those, and this becomes a sine 1/2 x. Okay, so then basically you've got a double negative here, so you could take that additional line of work in to make that minus minus into a plus, so it just becomes 2 sine, that is sine, not cosine, of 1/2 x. Okay, so yeah, that scenario potentially could require 2 lines of working, but if you end up doing enough of these, you'll recognize that double negative is going to come into play anyway. Right, let me just check my working again. Yeah, it's all looking good. Okay, so this one here, a little bit more difficult. This is when you require more focus on the fact that these numbers that we're pulling in front are not just the number that's in the internal bracket, but they are actually the derivative of that. So this time the thing that's going to come in front isn't the 3, because it's not, 3 is not the derivative of x cubed. The derivative of x cubed is 3x squared using the power rule. So the thing that comes in front this time is 3x squared. Sine differentiates to cosine, positive cosine, and then we leave that internal function the same. When you're starting differentiation, and differentiation of trig functions in particular, you're probably not going to see many that are in this format initially. They're probably going to be more of this kind of format where you're just pulling the number in front, just to kind of get used to the rule. As you get further into it, you're going to see different things in here, and that's when it's more important to recognize these different formats and to know that what you're pulling in front is the derivative of the inside of the bracket. So it is an application of the chain rule. Once you get to the chain rule, maybe you've seen the chain rule already. If you've not, once you get to it, you'll appreciate greater why we're using the rule here the way that we are. But for the time being, it's just really learning the form that the number comes in front or the derivative comes in front. So that's basically how you differentiate sine and cosine. I'm going off now to practice some sine and cosine derivatives myself so that I stop making mistakes. But they are very, very popular. So do spend a little bit of time getting used to these. As with all differentiation, try as many different formats as you can, just to avoid little pitfalls like not noticing a double negative, or things like this are a little bit more advanced. That is really the key to all differentiation technique practice, is trying a variety of examples. So hopefully that makes sense, and yeah, go ahead and check out some practice questions.